Hello, in this lecture we are going to talk about super and what does it mean to make a super message send. So before in the previous lectures we saw what it means to send a message, what it is the method lookup, and today we are going to extend the previous lectures with super message sends. So we are going to talk about the semantics of super and what are the differences with self. Those are the main topics of this lecture. So first, I would like that you take 5 minutes to try to write a definition of what is super and what does it mean to send a message to super, like in here. Yeah. Your definition should have 2 main points. So what does it mean super? So what does it represent? And what is the message that is going to be looked up in this message send? Now, you can also take 5 minutes here and try to answer these 3 questions. So imagine that you have these 3 classes, the class A, the class B, and the class C. So C inherits from B, B inherits from A. Yeah. They define methods foo and bar that are as they are defined in these little boxes here. And we have 3 different instances. So we have an instance of A that is instantiated like this. We have an instance of B that is instantiated like this. So we have an instance of A, an instance of B, and an instance of C. And we are going to send each of these a message bar. Take a couple of minutes to try to understand what will be the result of each of these expressions. If you did well, you probably reach these answers. So the result to send a message bar to an instance of A will be 10. The result of sending a message bar to an instance of B is 20. And the result of sending a message bar to an instance of C is 100. So how does it work? First, imagine let's take the third example that is probably one of the most interesting here. So we have an instance of C, C new. So the first thing that is going to happen, so is we have here our instance of C, and we are so this one is an instance of C, and we're going to send it the message bar. Yeah, okay, like this. So we send the message bar to an instance of C, and following the rules of the method lookup that we saw before, the first thing that we need to do is to search for the class of the object. So we see that the class of a C instance is the class C. So we are going to start the lookup there, and we're going to look for the method bar. So in this case, C doesn't define a method bar, so we are going to follow the inheritance link, and we are going to look for the method bar in the superclass. Here we find the method bar in B, and this method is defined as in here. So it's saying to return the result of superbar plus self foo. So now we need to define what is superbar. So we are here. So superbar is, of course, is another message send. So the thing that will change here is that super is also a reference to our instance C, but it will change the way the method lookup works. So here we're going to send the message bar to the object C, but we're going to start the method lookup in A. So we're going to start the method lookup in here. We're going to find the method bar in A as it is defined in here. We're going to execute self foo and send to at the instance of C. And of course, sending the message foo to the instance of C, it results in 50. That means that this one, it values 50. And then we are going to do self foo here again. And since self is also the instance of C, the result of this expression, doing the lookup in C and finding the method foo here again, it's also 50. So at the end, 55 plus 50, the result of our main message is 100. So what is the definition of super? Super actually changes where the lookup starts. So I already told you in the previous slide that super refers to the same object as self. Yeah, so it is the receiver of the message. Now, take a couple of minutes to understand and to try to define where the method lookup starts when we have a message to super. So, the answer is that the method lookup starts in the superclass of the class that contains the super expression. So, imagine that we have the same example as before. We have B, and we have here a super foo, and we have method foo in here, and we have foo. So, since this super foo expression is defined in the class B, the method lookup is going to start in the superclass of B. So, super is in B, and the lookup starts in superclass, yes? There is a main difference between self and super. So, self is really dynamic. At compile time, we don't know what kind of, where the method is going to be found, and what is the kind of object that is pointed by self. We only know that it is an object from the hierarchy, but we don't know if the object is low in the hierarchy, around here, or higher in the hierarchy. Yeah. So since we cannot know that, we don't know where the method lookup is going to start, and we don't know exactly at each call site what is the method that is going to be executed. Super, differently from self, is static. So that means that just by looking at the code and how it is organized, I know exactly where the method lookup is going to start, and I know what is the method that is going to be found. So here, for example, I know that superfoo is installed in the class B, so the lookup is going to start in A, and that means that I'm always going to find this method foo from this call site here. That is why we say that super is static, and it's defined at compile time. What you should know is that even some books get it wrong. So there are some books that will define super sense in this way. So super looks for a method in the superclass of the receiver class. What does it mean? Is that if I have an instance of C, I do a super send to an instance of C, it will always start from the superclass of its class. So in this case, it will take its class and start from the superclass B. The problem with this definition is that it may create loops. So this is not the right definition. So let's see with an example what happens here when I send to C, to this C instance, the message foo. What will happen is that we are going to send a message foo to a C, and with the first time, so doing a C foo, and this will do a normal message send with a normal method lookup. So it will take the C instance, it will take its class, and then it will look up, starting from there, the method foo. So C doesn't define a method foo, it will look up in the superclass B, and it will find foo defined as this. So this definition of foo will do super foo. If we use this definition that we saw before, super foo should start from taking the instance, the receiver, which is a C. It will take its class and then its superclass and restart the method lookup from there. So that means that it will start to look for foo from B. Starting from B, we'll find foo, the same method foo as before again, and it will execute the same method foo again. So this will loop like this. Yeah. Instead, with our definition, that is taking the place where the super expression is defined and going to the superclass to start looking for the method, this expression will actually do the following. So we take C, we send a message foo like this, we find this method first, and then we do the super foo. Super foo will start the method lookup from A, from the superclass of the method where the super is, and it will find the method foo defined above. So that means that this expression returns 10, and this expression, which is this expression, returns 10. What you should know is that self and super always represent the receiver. They represent the same object. So what you should think about is what happens if you do self equals super. So meaning here equals identity comparison, the one that really compares object pointers. So the difference between self and super is that super changes the method lookup. Self always starts from the class of the receiver object. In this sense, self sends act as a hook. That means that they can be redefined in subclasses to do different things. However, super always goes up in the hierarchy, so it can never be redefined by subclasses.